In this mandatory project, we will be using SPSS to demonstrate estimation procedures. The question we are trying to answer is, has there been a shift in the average number of people per household since 1961? We will require a sampling distribution of means to provide the best possible estimation of the population mean. The sampling distribution of means will be used to determine the degree of confidence that we have that the population mean lies within our chosen sampling distribution interval.
Once you've opened up SPSS, start by opening the 2006 Census Short and display names in alphabetical order, then switch to Variable View. Once in Variable View, go to your Analyze tab and go to Descriptive Statistics. Then scroll down to Explore. From here, move your HH size statistic over to the dependent list, as we have done here. Then make sure that your display is in Statistics. Click on the button Statistics and set your confidence interval to 95%. Press Continue and OK. Your output should contain the following table. For this chapter, we are only interested in the confidence interval and the mean. We would also like to note that the n is greater than 100. This is important to note because the textbook suggests that if an n is less than 100, the distribution of the sampling distribution of means will not be normal in shape. To help visualize our output, we are using an online resource called Online Statbook to represent how SPSS created the previous table. Here, we have a representation of a population. For the purpose of our experiment, we're going to create a population which is not normal in distribution. Here we are going to animate a series of graphs which are going to create a sampling distribution. Here, the tool has taken a small sample from the parent population and taken the mean of this sample and graphed the mean of that sample on a frequency table. If we do this once again, an additional mean will appear on our frequency table. We're going to do this 100,000 times in order to get a distribution which is normal in shape. Okay, so this graph right here is our online statbook output, and we've noticed that the online statbook output is the same shape as a normal curve, and what we know about a normal curve is that z-scores plus or minus 1.96 from the median happen to be the space in between those z-scores happens to be 95% of the normal distribution, and because our output from online statbook was also normally shaped, we now know that 95% of all means rest in between those z-scores. Those z-scores can then be computed into raw stat scores, which will then give us our confidence interval. From here, we will explain the confidence interval output from SPSS and other alternative methods of expressing the confidence interval. A 95% confidence interval for the mean means that we are 95% certain that the mean of the population will lie between the lower bound 2.89 and the upper bound 3.04. This is also often expressed as the interval between the bound, upper or lower, and the mean. One can perform a simple operation in order to define this interval. One can perform it as 2.96 minus 2.89, which equals plus 0.08, or it can be done as 2.96, that being the mean, minus the upper bound, 3.04, that being minus 0.80. This is often stated as plus or minus 0.08. The interval between the bound and the mean divided by the mean is also often used. This is the 0.08 divided by 2.96 to get 0.027, and this can be expressed as a percentage, plus or minus 2.7. With the 2.7%, we can now say that we are 95% confident that the population mean lies within 2.7% plus or minus of the statistic mean 2.96. Next, we want to construct an error bar. We start by going up to the Graphs tab, click on Graphs, Legacy Dialogs, and then scroll down to Error Bar. From here, we want to click on Summarize Separate Variable. We want to make sure that it is set to simple and click Define. We now want to select the HH size dataset and move it over into our error bar box. From here, we want to set a 95% confidence interval and then press OK. Your output should look as follows. This is an error bar. This represents the range in which we are 95% confident that the population mean will rest between. The circle here represents the mean of our sampling distribution. The upper limit represents 2.7% above our sampling mean, and the lower limit represents 2.7% below our sampling mean.
After determining that our 2006 statistic of 2.96 people per household is accurate to within 2.7% above and below the mean 95% of the time, we can now compare this statistic to the census report from 1961. iMovie is giving us difficulty, so we can't display this graph, but the information from StatsCan indicates that households have been continually becoming smaller since 1961, when the average number was 3.9. This rate change is well beyond 2.7% of the average, which means that there are other variables that must be changing the rate of people per household. Shifting family dynamics, including an increase in single-parent families and a lower overall fertility rate, may play a role in the lower number of average people per household. This concludes our presentation on confidence intervals, error bars, and sampling distributions. Thank you very much for listening, and we hope that it helped.